Hi, it's Jan Beta, and today I'm going to try to fix this broken Bad Monkey guitar effects pedal that I found on eBay. So if you're into guitar effects pedals and are watching YouTube regularly, you probably came across this thing, quite an interesting story. One of the big YouTube channels concerned with guitar effects, JHS Pedals, Josh, who runs the channel, introduced this thing and compared it to several other overdrive pedals, some of which are vastly more expensive than this thing, and this could reproduce all the sounds the way more expensive pedals could do. So the story was that this went up in price hilariously a couple of years ago, although it is really nothing special. These were made by Digitech in around 2004, so it's a 20 years old vintage guitar pedal, if you will, but these were discount pedals. They were, I think, around $39 to $50 when they were new, and they went up to like $600 or something like that, ridiculous prices a couple of years ago. Now the prices are somewhat back to normal. I paid 45 euros for this. It is broken. We're going to look into that shortly. But yeah, as I said, this is really nothing too special. It's a tube overdrive. It is a clone of the classic tube screamer pedals. Basically the same circuit, but this has a bit more sophisticated tone controls. This has a low and a high control. But other than that, it's pretty much a tube screamer. And it sounds like a tube screamer. And you can replicate many different sounds with that basic circuit, because many guitar overdrives just use a slightly modified or even unmodified tube screamer circuit. Very classic pedal, super nice sounding pedal. This one is just a tube screamer in a monkey costume. Yeah, I got this for 45 euros, as I said, because it is broken. But I think I'm going to be able to fix it, hopefully. Allegedly, this works, but stays on all the time, so you can't turn it off anymore with the foot switch. Might just be a broken switch, might be something else. We're going to take a look at this. Usually these go for a bit higher prices, so maybe if I don't like it on my guitar, I'm just going to resell it after fixing it, hopefully. But maybe I like it enough to just keep it, and it's kind of an oddity, an internet oddity, so nice to have anyway. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding, so everything you need to maybe build your own guitar effects or other electronics projects. Their service is excellent, the pricing is super reasonable, so check out the link in the video description in case you're interested. Back to our bad monkey. So at this point I can already see that there's still a battery in there. Don't know if you can see. Yeah, now you can see it from this angle. 9-volt battery is in there. That has probably leaked. And there's some corrosion on these sides here. So maybe we have a badly corroded board inside. So the first step I'm going to take is to take the old, probably leaky battery out there. And the way you do this on these Digitech pedals is to just take your guitar plug and push into one of these little... Ooh, that's badly corroded indeed. You push in one of these pins on either side, or on both sides if you want, but you can take the whole lid off then and get to the battery compartment. And indeed, the battery has seen better days. Yeah, this one's badly corroded. So we're going to have to do some corrosion repair. And we can already see the little tactile button down there. That's the thing that switches the whole pedal on and off with this little rubber nubbin that's in here that pushes down on that. And then the switching is done by the circuitry. There's a logic chip that latches the on and off positions. Let's see what it does. At this point, I guess I can reach this and see if it, let's see if it turns on and off if I push this manually. Maybe it's just a mechanical problem. So just putting in a power supply and it's on as expected. I'm pushing the button. button doesn't do anything. The LED should technically turn off whenever the effect is disengaged. So yeah, it's on all the time. Allegedly, the guitar effect itself works, so the circuitry other than the switching does work, and we get a distortion or an overdrive. Okay, I got this hooked up to an amp simulator in my DAW. And it does work. Level works, the gain works. Tone controls work, so this is really a working effect. The only thing that doesn't work is switching it off. The switch doesn't do anything. Maybe it's just a broken switch due to some battery corrosion. We're going to find that out shortly. So first step is going to be popping off all the knobs, just setting them all to 0. But yeah, these are these half-moon shaped potentiometers, so no way to get these in the wrong orientation. These things need to be loosened, I think. And then we got 4 screws in the back to get the whole thing apart. Just using my pair of pliers here because I'm too lazy to get a proper tool. So and these are, I think, hex screws. By the way, I really like the effect. Actually, the second time in my life that I play through a tube screamer kind of circuit, and this one is particularly nice. So it's not a bad pedal at all, but not worth like $600. These are in there pretty good. So I guess this has never been opened. But usually guitar effects are pretty resilient. But if you spill a battery over them, it's probably not what they are intended to be resilient against. Sometimes the battery compartments are completely separate from the rest of the circuit, which makes sense. Of all the, I think, 3 pedals that I bought used, all of them had the batteries still in them, and all of them were empty. Thankfully, on the other 2, they were not leaking yet. But if you leave batteries in there, they are going to leak sooner or later. So there we go. We should be able to take this out after loosening these screws and removing the knobs. And yeah, we can just pull the battery holder out. Yeah, there's some dirt around the switch here. Can already see that, and some corrosion. So here's all that's in there, really. A couple of electrolytic capacitors that I might want to replace while I'm in here. The switch itself, and you can see these dark spots here around some of the components, and that's actually battery corrosion that has seeped into the layers of the circuit board. So I'm going to give that a good clean and hope for the best. And I think on the switch here, this is just a tactile push button. So it's just closing contact while you hold it down, basically. And the switching, the latch for the switch, basically, so you can push it one time and it stays on, is done in this chip, which is some kind of logic chip. 470G, 4007. I'm not sure. But yeah, that's basically all that's to it. And then there's a couple of diodes for the clipping and some polymer plastic capacitors for most of the tone circuitry, for the tone controls and input and output filtering and stuff like that. And I think the larger electrolytic capacitors over here are mostly for filtering the input voltage. So you got no noise in the signal. All the components are surface mount except for the jacks, the potentiometers and the larger electrolytic capacitors here. And the switch is, oh, it's surface mount. Okay, so that might be, no, it's actually not surface mount. It's soldered through the board here. There's the 2 contacts that come through. But this switch might actually be compromised quite a bit because the leakage happened around here. Because the battery compartment has an opening here. I'm going to do a first pass with some isopropanol, I think. So it's just alcohol, that's 99.9% that I'm just going to spray on there and rub it off with a brush. Maybe that even fixed it already. But I think I'm going to have to do some more cleaning on these components there and maybe use some force, like a glass fiber pen or something like that to get the corrosion off. And after cleaning, I think I'm going to check the little tactile switch there. Brushing this off. This was a sticker and it's also corroded away. I think this was a reflective barcode sticker here. You can see that parts of it have turned green or translucent. So anyway, I'm just going to clean this up as good as I can and then check the button. So I got my multimeter out here in continuity testing mode. That means it beeps if there's continuity between these two leads. Okay, I think the button is shot. Yep. Button is gone. I'm touching these two, that's just me slipping, touching these two contacts on the back here and pushing the button and it does nothing. So it's just a broken button in the best case. Not sure if I have one exactly like this, but we're going to see. I sprayed some contact cleaner into the switch and let it soak for a while and moved it a bit, but it's still not great. So there's definitely some corrosion going on in there. And I don't have the exact replacement for it, but I have something like this, which is super similar, but this has 4 legs instead of the 2 legs in the center. This has like 4 legs on the sides. And I think what might work is to just put this in here like diagonally, like this. Maybe that's a good workaround. It's technically the same tactile button, very similar in height and diameter and things like that. So it should be actuated by this rubber blob here. Anyway, and this is a lot clickier. I'm going to desolder this and try to fit this in there. This is definitely shot. Yeah, there we go. That's the culprit. And there's some corrosion going around the pins there. So you can pretty clearly see the dark spots around here. This pad on the bottom here is only connected to ground. That means it's connected to the whole inner layer of the circuit board and to the outsides of the jacks and things like that. And the other thing is switching one of these resistors to ground. One of the pins on the chip is pulled to ground by hitting the switch here. So what I'm going to do is to use my fiberglass pan here to scrape away some of the solder mask and some of the corrosion, and maybe we can see a bit better. This is a tiny circuit, these components are super tiny, but I'm still going to try to clean this up a bit and see if we can make things visible a bit more. You can see how easily that rubs off. So yeah, the solder mask is not very resilient in these spots where there is corrosion. And you can see that there's copper underneath. And we have a huge copper layer here on top, that's a ground plane. But this area here around the components is what I'm worried about here. And also it's a good idea to get rid of all the corrosion, because it's going to continue to corrode as long as it's in there. You can see some of the connections there a bit better, and this actually goes to the back side. Yeah. Let's see if we have connectivity from there to there. So this resistor should be connected to our switch here, which it is. And where does that go? Somewhere on the chip directly? Yep. Okay. It goes to the other resistor through a capacitor, it seems. So yeah, we need some more corrosion repair here. Okay, but it actually doesn't seem that bad. I think the traces should technically be all there. This trace here maybe. So the way this works is this pin here is pulled low when the switch here is closed. So yeah, so this is connected to this resistor in the center here of these three components. And then these three components are all connected on this side. I think they are. Yep, and that works. And then this side is connected to ground on this capacitor. And this resistor here is connected to this pin on this side. So this pin is pulled low, I guess. Yeah. And the capacitor, this little brownish looking thing, is just here to debounce the switch basically. But it's all, the connections are all there, it seems. Yeah, but if we ground this pin here, this resistor, it should technically switch the effect on and off. Yeah, so it does work again, I think. Yeah, when I short this out to ground, it is switching back and forth, just like it's supposed to do. Neat! So I'm just going to clean this up a bit better with some actual cleaner for circuit boards, which should get rid of everything that we don't want on there. So this here is some UV curable solder mask, and I'm just going to brush some on there. This stuff is pretty nasty, so I'm wearing gloves, but yeah, we can just get some out here and basically brush it on. After determining that all the parts of the circuit we want to use or repair are good. But this just helps seal the circuit board against corrosion, general corrosion. And as I said, it's UV curable. Came with a little UV light. You can also just use nail polish or something like that. This is kind of overkill, but I have this stuff, so I'm using it. It has served me well in the past. So yeah, this is literally the cheapest product I could find. And then we just shine this UV light on there, and it should cure in a matter of, I don't know, a minute or so. So I'm just going to use my soldering helper here to prop it up. Just positioning it like this, and I'm going to wait for a while. And while I'm curing the UV curable solder mask, I'm just going to give the case parts a good washing in some dish soap and some warm water and some vinegar on the pieces that got in contact with the battery acid. Or it's not really acid, it's basic, really. So vinegar is neutralizing that. Yeah, just going to do that off camera because it's not that interesting. So this should actually be cured now. Yeah, I don't get any green spots on my fingers. Looks reasonable enough. Yeah, let's see if we can solder in this non-fitting switch here. And for that, we're going to have to clip two of these legs off. So I'm just going to bend them upwards, something like this. And we're going to clip them very close to the switch body. Yeah, but that should do. And now we only have to fit these into these holes, which should technically be possible. And probably would be a very good idea to get a proper fitting switch for this. But where's the fun in that? Okay, this is kind of not such a great idea. But hey, we got both of the legs through. Just going to pull them in a bit. It should be the exact correct position. So yeah, I'm just going to solder this in and see if this works actually. Should be able to test this before we even solder it in, I guess. Let's see. Okay, now it works. Most of the time. Maybe that's just because the switch doesn't make perfect contact with the circuit board. Soldered this in. On, off, on, off, on, off, on, off. Okay. It seems to work again. Now we only have to see if my diagonal switch here fits with the switching mechanism. And actually, while washing the case parts, I poured white vinegar on the parts that were corroded quite badly and the little sponge thing that held the battery in place. And it made a fizzing sound. So there was a chemical reaction neutralizing the battery leakage with the vinegar. So that's a good idea. I'm just going to let that soak for a while in vinegar and then clean it off and rinse it out completely. And I think we can get away with that. Would be a better idea to replace the sponge altogether, but I think I'm inclined to not do that because I'm not going to use this with the battery anyway. I'm going to try to clean the battery holder here a bit more because that's really badly corroded. Maybe some vinegar in that too. So I'm just going to soak the whole battery holder thing in some vinegar, I think, because it looks super green on this one terminal. You can see that. So let's just pour some vinegar over that. Let's see if we get some bubbles. Yep, definitely. Woo! Okay, that's the reaction you get when it's actually doing its job, neutralizing. And we're going to have to wash this thoroughly again afterwards. But you can already see that the green stuff is pretty much gone. That's a really quick process, really. It's all neutralized chemical reaction. And that is a good idea, whether you want to use this or not, because the corrosion keeps on eating away. We're just going to have to wash this thoroughly with some water. And I'm probably going to finish up with some alcohol. That was pretty impressive. I hope I caught that on camera. This is not green at all anymore at this point, so that's pretty nice. And of course you have to remove the vinegar completely, because otherwise the vinegar is going to do the same corrosion, just from the opposite end of the chemical spectrum, with its acid, not with the base, the basic stuff. So yeah, let's wash this with some distilled water, which I should have here somewhere. There we are. This is just water, distilled water, so it doesn't cause any more corrosion. And I'm going to finish off with alcohol, so the rest of the water is washed away by the alcohol, and that evaporates pretty quickly. So the electronic side of things looks pretty promising at this point. Okay, I just realized I don't even have to plug anything into this to switch this around. Now it works perfectly. I'm just going to spray some contact cleaner into all the potentiometers here. Potentiometers. That's always a really hard word. But I think you know what I mean. So this is a non-corrosive contact cleaner, Teslanol T6, which doesn't hurt potentiometers. And usually you can find some kind of opening where you can spray something in there. And then you just move them a bit to clean them and spray them again afterwards. And I'm doing the same with all the sockets here. Yeah, and for these you just want to plug in something and move it a bit to get rid of the dirt in there and clean the contacts. It's always the easiest way to do it. Then it should pretty much be back in operation. You can of course change the LED color and things like that. I would actually be tempted to put a yellow LED in there just to see that it's my repaired one. And I like yellow LEDs, and the Bad Monkey logo is yellow anyway. Maybe I'm just going to do that. I think the yellow LED I have here is not even long enough, but we're going to try. Of course you can replace this with some sort of fancier color if you like, but you would technically have to adjust the resistance values on the board. There's a resistor in series with the LED that has to match the LED. So you have to watch the voltage the LED takes. There we go. Okay, this should fit in here in this little holder. And it's too short. That sucks. I made the legs a little bit longer with some components leads that I had lying around. It's not the best idea probably, but it looks nicer than the original red LED, which I can always put back. No big deal really. But I like yellow because banana. So here's our results so far. Looks rather neat. Of course there's some carnage because of the corrosion, but I think it's not going to corrode any further in this state, and we sealed it off quite nicely. I am going to replace the electrolytic capacitors here, I think. For the other ones further down the circuit board, I don't have this size of capacitors, unfortunately. Would make sense to replace them all, but there's very little room in the case, which I also got back here, cleaned. Looks nearly as good as new. There's some scratches and stuff, of course, because this got stomped on quite a bit. So yeah, I am going to replace these capacitors on top here. I have some that might fit. They're a bit larger than the original ones, but yeah, there's a lot of room. These are sitting here behind the potentiometers, and it's going to fit, I think. We're going to see. And it makes sense because that's the voltage supply. Smoothing capacitors mostly, I think. Let's see if it still works. It should technically still work. Yep. Okay, let's put it back in the casing. Yellow LED actually looks pretty good. Just going to screw these down a bit. This spring-loaded, I don't know, axle. I'm just going to give it a little spritz with WD-40 to prevent further corrosion. This just goes in here like so. There we go. This thing goes on here. And then I can hear the switch activating there, or the button. Let's see if it actually activates. Wow, these really don't go in easily, just the way they came out. Not too easily. Yeah, our switch also works fine. And I think it doesn't work from a battery as long as I don't plug something in. There's the switch there. Yep, exactly. Okay, that's exactly what it is. So for now I'm just running this from a battery. And you can't activate it with the battery in there when there's no guitar plugged in, or this stand-in. That's a neat feature, because the battery would get drained otherwise. With the power supply it works without plugs, it seems. Working Bad Monkey pedal. So I guess that's it for today. Bad Monkey back in operation, and I think I'm going to enjoy this. Sounds pretty nice. Thank you very much for watching. Hope this was informative and maybe a bit entertaining. And there are schematics for this online that you can dig in case yours is more severely broken than this one was. This just had some battery corrosion, especially on the switch, as we've seen. So thanks for watching, thanks for your time. Special thanks, as usual, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. I'm going to be back with some more retro computer videos pretty soon. And even if you are a retro computer tinkerer, I hope you enjoy these little excursions into guitar land. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.